Out there, lurking in the vastness of space, are planets so strange that even science fiction could not have imagined them. For the first time ever, scientists are discovering alien worlds beyond our solar system, places where ice is hot and rain is made of iron. They are uncharted, unearthly, and unpredictable. And somewhere, hidden among these strange new worlds, scientists seek the greatest discoveries of all.
Hydraulics go. Storage tank press closed. Closed. Storage
March
tank
the 6th,
open.
2009.
2 seconds. Later, GN2 pressure go. Go.
This Delta II rocket is going through its final pre-flight check.
71.3.
Prop 1.
Engine start, 1, 0, and liftoff.
It is the start of an extraordinarily ambitious mission. The Kepler Space Observatory is hunting for Earth-like planets within a region of 100,000 stars. It is the culmination of a journey that began more than a decade ago, with one of the most profound scientific discoveries ever made. In 1995, Swiss astronomer Michel Mayor and his team make a routine observation of stars in the constellation Pegasus, located 50 light-years away. But the instruments show something strange. One star is violently lurching and wobbling.
What we discovered, it's one of these stars have a velocity changing with time.
What is powerful enough to disturb a star the size of our sun? Mayor offers a radical answer: a planet. But no one has ever seen a planet around another sun-like star.
Problem in detecting planets around other stars is that as a planet orbits a nearby star, that planet gets lost because of its feeble light in the glare of the very bright star.
In spite of the odds, Mayor relies on his data and is convinced the wobbles are caused by the gravitational pull of an orbiting planet.
When I read this claim from Michel Mayor, I was very skeptical. There had been many false claims of the first planet ever discovered around another star, and I thought to myself, oh boy, here we go again. So I decided to observe the star on 4 consecutive nights. And stunningly, the star was shown to wobble exactly as Michel Mayor had said.
Michel Mayor and his teammate Didier Queloz announced their discovery. It rocks the scientific community.
They had found for the first time reproducible, confirmable evidence of the existence of a planet around a sun-like star.
Officially called 51 Pegasi b, the planet is nicknamed Bellerophon in honor of the Greek hero who tamed the winged horse Pegasus. It is a planet that breaks all the rules. Bellerophon roasts in the blazing starlight at temperatures of roughly 1,800 degrees Fahrenheit, almost 1,000 degrees Celsius. It is nearly 150 times more massive than Earth and is a gas giant like Jupiter.
A gas giant is a planet made mostly of hydrogen and helium. Only the outer layers are gas, but inside, hydrogen and helium is compressed to huge, huge, huge pressures. It doesn't resemble a gas at all.
Unlike anything found in our solar system, this is an entirely new class of planet, what scientists call a hot Jupiter.
If you go to Hawaii and see the lava flow there, that's how hot a hot Jupiter is. It's very, very hot.
The Earth is a comfortable 93 million miles, or 150 million kilometers away from the Sun.
These hot Jupiters are roughly 100 times closer, and so the amount of sunlight that they get is 10,000 times larger.
If this represents a star, and this a hot Jupiter is 3 to 4 stellar diameters away from the star. So that would be 1, 2, 3. This is how close a hot Jupiter would be to its star. Hot Jupiters are tidally locked. They present the same face to the star at all times, just like the moon does to Earth.
It's going to be permanent daylight on one side and permanent nighttime on the back. If I were stuck on a hot Jupiter, I'd want to be on the back side and hope that some of the heat from the front side facing the star would make its way around the back.
The variations in temperature make Bellerophon's atmosphere extremely windy. As the air is cooked by the star, it rises. Cooler air rushes downward to replace it, just as it does on Earth. The wind howls at thousands of kilometers per hour, far beyond anything we could ever withstand. The heat blast guarantees water vapor cannot exist, but that doesn't mean there is no rain.
It's far too hot for water liquid clouds to form here, but instead these clouds would be made out of iron.
Iron vapor can exist at much higher temperatures than water. And because of that, things could get a little messy.
You better have an umbrella that's pretty sturdy, because the iron is going to start coating your umbrella very rapidly and making it extremely heavy and just crush that umbrella.
The sky overhead is filled with dancing curtains of color. Charged particles from the nearby star make auroras far more extreme than the northern lights on Earth. There is something else unique about this newly discovered world. Bellerophon orbits its sun in a blistering 4.2 days.
No self-respecting planet goes around a star in 4.2 days. None of the planets in our solar system take such a short amount of time.
For scientists, the tiny orbit challenges long-held notions of how planets form.
The fact that the planet was orbiting every 4 days was a total puzzle until one night in the middle of the night I woke up and said, well, this must be proof that planets migrate inwards. They don't stay put where they are.
The key to the puzzle is found in how planets are made.
Planets are a byproduct of star formation. When stars form, they have a disk of dust and debris around them, and out of that debris, planets form.
Much of what we know comes from the Hubble Space Telescope, as it aims at regions like the Eagle Nebula. This interstellar cloud is studded with collapsing disks of dust and gas. A giant clump grows in the center of each disk. Temperatures reach a searing 10 million degrees Celsius. The same nuclear fusion that powers our sun is unleashed. The star is born. Radiation from the star generates a stellar wind that sweeps away leftover dust and debris. Some of the dust survives and remains in orbit around the newborn star. Over millions of years, the dust sticks together, forming knots that grow into asteroids, and the asteroids grow into planets. These planets migrate through the disk until they find a stable orbit. This is why Bellerophon is so close to its parent star. But one newly discovered world has found its stable orbit in a place no planet should ever go. In 2001. The Hubble Space Telescope is directed to an obscure star some 150 light-years away from Earth, in the constellation of Pegasus. This is the same region where Bellerophon was found 6 years earlier. Hubble is tracking another hot Jupiter, discovered by astronomer Jeff Marcy. But this one is different from Bellerophon.
You've probably heard of the planet HD 209458b. It's a terrible name.
A terrible name for a terrible place. HD 209458b has been dubbed by some as Osiris, after the Egyptian god of the dead. Osiris is over 200 times more massive than Earth. It has migrated perilously close to its sun. At a mere 4 million miles, or almost 6.5 million kilometers from the blazing solar surface, Osiris broils in a planetary hell. The average daily temperature on Osiris is over 1,000 degrees Celsius. Forget global warming. This is global frying, and it causes Osiris to lose an estimated 500,000 metric tons of air every second.
There's a leak of gas, a steady stream of hydrogen and helium, and that's making a big, huge cloud all around the planet.
Its atmosphere is bleeding into space. Scientists speculate that a colossal trail of gas spirals behind the planet for thousands of kilometers. Osiris presents an unprecedented opportunity for astronomers. Using Hubble, they analyze the alien planet's bloated atmosphere.
This is the absolutely first time where we could tell what is the composition of the atmosphere of an extrasolar planet.
Surprisingly, Hubble detects many of the basic chemicals needed for life. Sodium, carbon, hydrogen, and oxygen. But Osiris is far too hot for life as we know it.
There may be other forms of life, however, that thrive on higher temperatures.
But there's no solid surface as we know it on a hot Jupiter. So this life would have to be just tiny little microbes floating around on aerosols. And on our own Earth, we have life that floats around in our atmosphere. But that life didn't start there. So life almost certainly would not exist on hot Jupiters.
Astronomers have discovered many hot Jupiters since Bellerophon was found in 1995. But conditions on these worlds rule them out as places where the drama of life can unfold. However, one of these gas giants is a planet that teases the rules of evolution. Astronomer Jeff Marcy discovers something shocking about a planet orbiting a star called 16 Cygnus b, located some 70 light-years away in the constellation of Cygnus, the Swan.
The planet was clearly in an elongated orbit, bringing the planet close to and then far from the host star. And this, of course, defied our expectations based on our own solar system, where all of the planets go around our sun in nearly circular orbits like phonograph grooves in a record.
Like a giant yo-yo in space, the gas giant swings back and forth across its solar system. That's like the Earth swooping 25 million miles, more than 40 million kilometers closer to the Sun, then slinging past Mars all the way out towards Jupiter every year. And like all of the gas giants in our solar system, this yo-yo planet probably has an entourage of moons. Marcy speculates that one of these moons could be similar to Earth.
And here's where the interesting story begins. Imagine a rocky moon with lakes, oceans, maybe streams and waterfalls on the surface. The moon orbiting its planet, the two of them orbiting the host star.
Unlike the airless moon that circles the Earth, this moon is a world with extreme seasons. On Earth, the seasons are caused by the tilt of our planet. Here, they're caused by the elongated orbit.
These poor planets that are in these elongated elliptical orbits suffer terrible changes in their climate throughout a year.
As they make their closest approach, the yo-yo planet and its moon are blowtorched by the star. Summer begins. The atmosphere on the Earth-like moon is savaged by raging storms. Category 5 hurricanes on Earth are tiny eddies compared to the monster vortexes that form here. The clouds thicken as the water evaporates.
Temperatures rise dramatically. Any water or gases would heat up, and indeed the oceans would boil into steam, so you'd end up with a big steam bath.
During the peak of the summer, the entire moon is smothered in temperatures of more than 400 degrees Celsius. This is the closest approach to the star. During its 26-month orbit, the summer season is barely 2 months long. But what a season! The planet and its moon swing away from the furnace of the star. Temperatures fall to ranges we would find temperate and comfortable. With the coming of autumn, the rains return to the parched and roasted moon. Dry ocean basins are replenished, and the seas arise to form new shorelines. Tranquility prevails as the yo-yo planet and its moon slip into the deep freeze of winter. Now over 200 million miles, more than 320 million kilometers from the star, the daytime sky is dark. Temperatures hover around minus 160 degrees Celsius. The oceans freeze, and the polar ice caps expand across the moon's surface into a globe-girdling sheet of ice many kilometers thick. Winters are long, lasting 17 months. With the coming of spring, the sun looms large in the skies over this hapless moon as the ice cracks and melts violently. Huge icebergs carve into a stormy and fast-rising ocean. For 2 preciously short periods, during the spring thaw and the autumn rains, the climate on this Earth-like moon is balmy and comfortable. At a distance of 93 million miles, or 150 million kilometers from the star, roughly the same distance as Earth from the Sun, the elliptical orbit of this planet and its moon crosses an area around the star some scientists call the Goldilocks zone. The conditions here are just right for life.
If you're too close to the star, then it's too hot. If you're too far away, then it's going to be too cold and everything's going to be icy. But then if you're right in the middle, it's just right.
Every star has a Goldilocks zone. Where that zone is depends on the size and temperature of the star. In our solar system, Venus marks the inner boundary and Mars the outer boundary. Earth and its abundance of life is right in the middle. The Yo-Yo planet passes through the Goldilocks zone twice a year, for 3.5 months during the spring as it races inbound, and again in the autumn for 3.5 months as it hurtles back into the colder reaches of space. Could life survive the conditions outside the Goldilocks zone?
There could be life forms that are smart enough to hibernate, as do animals on the Earth during the winter season. If this sounds fantastic, I offer you the tidal zones on the Earth. On the tidal zones, life proliferates, of course, near the seashore, and they do so despite tides. The water coming in, covering many of the life forms, the water going out at low tide, and yet those species survive perfectly well.
The strange cycle of the Yo-Yo planet's orbit creates fleeting conditions suitable for life, but also for death. Some alien planets are even more bizarre. Imagine a world that has no star to orbit. Scientists speculate that our galaxy is teeming with rogue planets, adrift in the murky lanes of interstellar space. These are orphaned worlds, planets that are booted from their solar systems by the chaos of planetary migration. Astronomers call such worlds planemos.
Planemos are planets without a star. They're just drifting through the galaxy indefinitely.
What massive force would it take to kick a planet out of the solar system?
When a young star forms with a contingent of planets around it, many of those planets gravitationally interact with each other. They yank on each other, slingshot each other, so that one of them is ejected from the planetary system, voted off the island, if you will.
If you were, unfortunately, a resident on a planet that was kicked out by a collision or a near collision with another large object, you'd probably rapidly move out of the habitable zone.
There are hundreds of billions of these lost, wayward, poor, wandering planets out in our Milky Way galaxy with no parent star to warm them up.
Cold, dark, and quiet. Because planemos have no sun, they are worlds without days or years. They keep vigil through an eternal night. Planemos are solitary wanderers, sentinels of the galaxy. But just because it's out there drifting in space doesn't mean a planemo is dead.
If the planemo is a rocky world, it could well have life on it.
A small rocky planemo without an atmosphere will slumber in extreme cold, far colder than the coldest winter's day at our own South Pole. But a planemo large enough to retain an atmosphere traps the heat generated when the planet was first formed. It is the ultimate greenhouse effect. The heat and energy comes from the molten core deep inside the lonely planet. If the Planemo is a gas giant like Jupiter, it may have a system of moons. The gravitational pull between the Planemo and its moons creates friction, causing the interior of the moons to stay warm.
These moons could also have life on them, in the same way that Jupiter's moon Io has volcanoes and has a lot of heat energy being generated by interactions with Jupiter and the other moons.
If anything lives here, it will be single-cell organisms like common bacteria found on Earth, not complex life forms. Without a sun to provide photosynthesis, these tiny organisms derive their energy from the chemistry in the soil of the Planemo or its moon. Similar conditions do exist on Earth. Colonies of bacteria are found deep within mine shafts in South Africa. They have no access to oxygen or light and survive entirely on the chemicals they make from the surrounding dirt. Their metabolisms are extremely slow, and they reproduce only once every 1,000 years. If life dwells on a sunless Planemo, it could be organisms like these, marooned when their planet was young. While Planemos slumber undisturbed, one world has been racked by chaotic changes since the dawn of time. In 2003. Astronomers confirmed the existence of a relic from the dawn of time in the constellation of Scorpius. Most planets found outside of our solar system are located in the main disk of our galaxy. But this world is perched high above the plane of the Milky Way in a cluster of nearly 10,000 primordial stars. The planet B1620-26 is better known by its unofficial nickname, the Methuselah planet, after the oldest person in the Bible.
The reason this has been known as the Methuselah planet is because that cluster is about 12 billion years old or so.
Earth is a planetary teenager compared to old Methuselah. Roughly 8 billion years before the Earth is formed, Methuselah is a young gas giant, perhaps with raging tempests and an entourage of moons. Eons pass, and the winds and the storms abate, leaving behind a peaceful world. Suddenly, 2 stars loom in the sky. These are the burned-out cores of long-dead stars haunting the cluster.
In the very dense environment of a globular cluster, you have lots of stellar collisions, near collisions, systems in which one star is kicked out and another one kicks in.
In a cosmic dance of gravity, similar to the migration of planets, one of the stars is kicked out and replaced by Methuselah's parent star. Methuselah is now a planet with 2 suns. Every day has 2 dawns and 2 sunsets. Every cloud and every object casts 2 shadows. Over time, the original parent star begins to expand, a sign that the star is dying. It swells until it becomes a giant red star and spills onto the neutron star. The neutron star devours the red giant. Today, Methuselah is a world imprisoned by the skeletons of two dead stars, the stripped core of the red giant and its companion, the pulsing neutron star. Methuselah is a survivor. But nothing compares to the weird anomaly of a pulsar some 980 light-years from Earth in the constellation of Virgo. From afar, a pulsar looks like a blinking light, but up close, pulsars machine gun their surroundings with deadly radiation. They are no place for planets. Yet something interferes with the precision of this pulsar. One explanation is that the anomaly is caused by a planet. But many astronomers are skeptical that planets orbiting a pulsar can exist.
The reason that's a problem is because pulsars are formed in these incredible explosions.
When a red giant star explodes, a titanic fireball known as a supernova unleashes as much energy in 1 minute as our sun generates in a lifetime.
When a star goes supernova, the shockwave is so immense it's hard to imagine any planet surviving that.
When the cosmic dust clears, all that remains is the crushed core of the red giant, pulsing in the heart of an expanding debris field. Matter blasted from the colossal explosion falls back to the pulsar and forms a disk. Within this chaos, a new world arises, born from fire and destruction, a planetary zombie raised from the carcass of the former red giant star.
It's amazing that planets could form in that environment.
A planet orbiting a pulsar will give you the feeling of being in a disco bar with a very strong strobe light, which is the pulsar.
Radiation from this stellar beast breaks down the organic molecules needed for life.
The pulsar has these very strong magnetic fields that are being spun around as the star is rotating quickly, and it's picking up any material, electrons, protons, and speeding them up and slinging them out at high speeds. So it's like a solar wind with a vengeance.
I can't imagine that there would be much of an opportunity for even simple life, microbial life, to emerge and to flourish on a planet around a pulsar. Largely because if you were in the pulse, you'd be severely energized, and if you were not in the pulse, you would be completely devoid of energy.
The discovery of pulsar planets shows how new worlds can form in the wake of a star's destruction. No matter where a planet arises, the process of its birth is fraught with danger. Sometimes the violence is so great, the end of the world comes before the beginning. 2007. Astronomers using the giant Gemini North Telescope make a strange discovery in the Pleiades cluster, some 400 light-years from Earth. A star known only by its catalogue number HD 23514 is surrounded by a giant donut-shaped cloud of dust and gas. The star in the middle of the donut shape is about 100 million years old, a cosmic toddler in astronomical terms. Our Sun is 45 times older. The conditions are perfect for planets to form. But spectral analysis finds something strange. The dust is utterly pulverized. Typically, a newborn star is surrounded by fledgling planets.
Planets form around the young star in a protoplanetary disk of gas and dust. And then these planets go on their merry way orbiting the star, not realizing that they're in an orbit that's too close to another planet.
Billions of years ago, two primordial planets orbiting HD 23514 are spinning towards doom. As the two worlds close in, tidal forces torque each planet from spherical to egg-shaped. The two worlds are annihilated, creating the dust and debris seen around star HD 23514.
There is a new planet out there, a planet we were not aware of existing before.
It is not just one planet, it is a new type of planet, Earth on steroids.
I like to call them super Earths. They're just like the Earth, except bigger, up to about 10 times the mass of the Earth. One family that the super Earths resemble just like our own Earth, continents, oceans. Some of them may be very dry, like Mars. And then another family that we call water worlds or ocean planets that are completely covered with water.
Welcome to Gliese 581c.
This planet was found by Michel Mayor, and it orbits with two other planets around a very small star.
It is only 20 light-years away in the constellation of Libra, and is one of the smallest terrestrial planets found beyond our solar system. But that doesn't mean Gliese 581c is small. It's still a super-Earth with 5 times the mass of our home planet. And it is the possibility of finding liquid water that gets scientists excited.
An ocean planet feels like being in the middle of the Pacific Ocean, with no land in sight, just water, puffy white clouds, and blue sky above you. The winds on the ocean world are going to be similar to that of the Earth, so it will be a very good place to sail.
The weather's absolutely perfect. Every day you get a clear blue sky, and the sun just stays in the same place. Now, how's that for weather prediction?
No land anywhere, even far beneath the surface.
When you have a large amount of water, then at the bottom of an ocean, you will form very high pressure in excess of 1 million atmospheres. And that pressure will compress the liquid water, that is the ocean, into a state which we call Ice 7.
No, it's not like ice in your refrigerator. The molecules of water that are in the ice in your refrigerator are kind of all jumbled up. But if you form ice under very high pressure, then the water molecules can become ordered, they can become aligned.
I can show you a crystal that is a very good analog to Ice 7. This is halite, also known commonly as rock salt.
Ice 7 may exist within our own solar system. Europa, one of Jupiter's moons, may have a mantle of liquid water surrounded by a thick, icy crust. The pressure from the crust is so great that Ice 7 might exist deep within these uncharted seas. If we scale up and thaw out Europa, it may be a water world similar to Gliese 581c.
One could imagine that life could emerge on a water world. After all, water is essential to life on Earth.
Everywhere on Earth where there is water, there is life. You cannot find a sterile drop of water on Earth unless you put it in the microwave yourself.
On this water world, there could be bacteria or any kind of life in the ocean itself.
But not all super-Earths are water worlds teeming with life.
When we talk about super-Earths, we talked about two major families of mostly rocky with some water and mostly water with an endless ocean. But one has to add to those a third family of probably very rare super-Earths and Earth-like planets, which are called carbon planets.
A carbon planet is unlike anything we've ever seen anywhere. A place with an alien chemistry, but loaded with very earthly treasures. Throughout our galaxy, there are planets which are barren and poor and inhospitable. But science is on the trail of a new type of planet, an entire world of treasure.
In our own solar system, in our sun and in all the stars nearby, there's always more oxygen than carbon. But if we think of a place in the universe where there's more carbon than oxygen, then planet formation is very different.
Spectral analysis shows carbon to be far more plentiful 26,000 light-years away, near the center of our galaxy. Planets that form here may contain a rich abundance of carbon. The morning sky on a carbon world would be anything but crystal clear and blue.
I'm picturing a yellow haze with black clouds of soot. And as you descended farther down in the atmosphere, I could imagine lakes that were made out of compounds like methane or gasoline. I'm picturing these bubbling, foul-smelling pits of black ooze, like an oil well.
With little or no water in the atmosphere, the air is made of carbon compounds.
Methane, butane, pentane, benzene, all these different kinds of carbon compounds that separate out when you refine gasoline. One day it might be raining benzene. The next day it might be raining butane.
As alien as carbon planets might seem, the air quality could be familiar to some.
The air in a very benzene-rich planet will resemble that of LA. A lot of smog particles that unfortunately we are quite used to from the exhaust of cars.
Despite the pollution, carbon planets could come with a sparkling upside.
You might see diamond because the planet may have substantial quantities of pure carbon that it's formed out of. And pure carbon, when you compress it, tends to form into diamond.
The secrets of exotic planets like these are waiting to be discovered all across the galaxy. But astronomers won't be satisfied until they find the Holy Grail, a planet like our own, one that sustains life, the next Earth.
People always ask me, do I think we're going to find another planet like Earth? And I answer, absolutely.
Every star is likely to have planets roughly the same size as our Earth.
We think that essentially every star has several Earth mass or super Earth mass planets. So if you have, say, 200 billion stars in the galaxy, that may mean there are 400 billion Earths in the galaxy or more.
400 billion Earths. The Kepler Space Observatory is the first instrument capable of finding one of these planets.
Kepler is looking at the constellation Cygnus in the night sky at 100,000 stars, taking picture after picture after picture, minute after minute. And the goal of Kepler is simple: to look for stars among the 100,000 that dim.
When a star dims slightly, it means a planet is passing in front, blocking some of the light. How long the star dims and how much light gets blocked will tell scientists about the size of the planet and the distance from its sun.
A good analogy for this is looking for the dip in the light that you would see from a searchlight if a small moth flew across the searchlight. And so it's a really tiny dip in the light as the planet transits.
It is a very powerful technique because it allows you to discover planets that are even smaller than the size of the Earth around stars similar to the Sun.
It is a technique that is changing the course of science.
We think we may be able to find a planet that is habitable in the next few years.
Scientists estimate that the Kepler mission will find a minimum of 50 alien Earths.
One of the big questions that anybody looking for life beyond the Earth is facing today is, what if we don't recognize life even though we discover it?
Conditions on an alien Earth may cause life to evolve differently.
My hope is that we'll see some sign that will make our hairs stand up on the back of our necks.
Whatever that sign is, it will be the first chapter of the greatest scientific story ever told.